Okay, let's talk about section 11.3. Ellipse. First, let's give the definition of the ellipse. An ellipse is a collection of all points in the plane the sum of whose distances from two fixed points those two fixed points, two focuses, because of focuses is called foci, is a constant. Okay, so basically it says the sum of two distance is a constant. The sum of two distance is a constant. For example, assume you have two fixed points because you have two focuses, two foci. You can just place them in whatever way, like this, and then you get another point, the third point. You measure the distance. Okay, so you have PF1. This means the distance of the segment or the length of the segment plus PF2. It is a constant. And you may have a point P here, possibly you have a point P here. This is all the same number. The sum is the same constant. Okay, and you just let this P move in whatever possible way you possibly, with a computer or with some smart drawing technique, we can see that the ellipse looks like this. Like an egg. Okay, so this is the ellipse. For one ellipse, there are two focuses. The plural is the foci. There are two foci. The sum is a constant. That's it. Okay, and there are some concepts. So those 2 points, two foci, determine a line. This line is called the major line. The line containing the foci is called the major line. Major axis. The major axis. Okay, the major axis. And 2 points. There's a midpoint. The midpoint here is called the center. The midpoint of the line segment joining the foci is the center. So here is the center C, center. And at the center, you can draw the orthogonal or perpendicular line. This is the right angle. And this, the line through the center or through the center and the perpendicular to the major axis is the minor axis. Okay, so this is a major, this is a minor. Major axis and a minor axis. Okay, and these 2 points, the intersection between the major axis and the ellipse, the 2 points of intersection, 2 points of intersection of the ellipse and the major axis are called the vertices. V1 and V2, whatever, it's V1 and V1 and V2. So this is a vertices. Okay, and from V1 to V2, this length, the distance from one vertex to another vertex to the other vertex is called the length of the major axis. The length of major axis. Okay, so that's basically the important concepts. So you have ellipse, that's an important geometric object, and then you have two foci, two foci, and you have a major axis. Major axis means that the line through two foci is a major axis, and the midpoint of two major axes. The midpoint of two foci is called the center. So this is the center. At the center, you draw the perpendicular line to the major axis. You get the minor axis. This is a minor axis. And the intersection of ellipse and the major axis are called the vertices. And the distance between two vertices is called the length of the major axis. This is the length of the major axis. Okay, so these are all the geometric concepts. That's all the geometric concepts. Okay, now we want to make an algebraic expression for the geometric concept. What does it mean? We are looking for an equation which can represent an ellipse. Okay, we want to find an equation representing an ellipse. How do we do that? There are several things. First, those two foci, we need to place them in the proper place. If we place this way, possibly the computation will be very complex. So first, we are going to place those two foci properly. When we place them, there are two choices. Either we place them on the x-axis or we place them on the y-axis. You see here, at this moment, we have two choices. We put foci on either x-axis or y-axis. So it means we have two standard forms. So we have two standard position. We have two standard positions. Now let's look at the first one. And also when we put them on the x-axis, we want it symmetric. So we are going to put the center at the origin because center is a midpoint. So F1, F2 are balanced with respect to the center. So first, we put the center at 0, 0. We put the center at 0, 0. So this is the setting. This is F1, this is F2. F1, F2. Because they are balanced, the distance from the center to F1 and the distance from the center to F2 are equal. So we just give this C. This distance is C. This distance is also C, but it's on the left-hand side, so the coordinate is negative C. So two foci, one has coordinate negative C0, the other one has coordinate positive C0. Okay, so that's the setting, the standard setting. So the distance at this moment, the distance between F1 and F2 is 2C. Okay, so these two distance is this distance of the 2 points is 2C. Okay, so that's a setting. And the second, check here, we're going to have a point P so that the distance PF1 plus the distance PF2 is a constant. Constant. What is a constant? Constant, we can put it whatever letter we want. Constant can be 10, can be 5, so we are going to use a letter to represent the constant. But because here there's a 2, coefficient 2, so possibly it's better for us to denote the constant by 2a. Okay, so the constant, the distance, the sum of PF1 and the PF2 is equal to 2a. It's not just we put a there, we put it as 2a. To balance is 2c, the distance is 2c. So here the sum of the distances is called 2a. Okay, and this point is x, y. The general moving point is called has coordinates x and y. Okay, now let's see. PF1, the distance PF1, x minus c, negative c, x minus negative c square, y minus 0 square, and plus PF2, x minus c square plus y minus 0 square is equal to 2a. Okay, so you see here we have square plus square, radical function plus radical function, radical expression plus radical expression equal to certain number. That's something we did before, but during that lecture we have some concrete number. Here we have letters. That's the only difference. So what do? We're going to move one term to the right hand side and square two sides. Okay, so let's move this to the right hand side. X minus negative c is x plus c. So it's 2a minus square root of x minus c squared plus y squared. Okay? We square two sides. You square left hand side, you cancel the square root. You square right hand side, remember it is let me put it here. U plus minus u minus v square is u square minus 2uv plus v square. This is a formula we will use. So this is u, this is v. So u square minus 2u v plus v square plus v square. Okay? And let's see, we are going to cancel as many as we can. Y square cancel. X plus c square is x squared plus 2xc plus c squared. 4a minus, this is 4a square root of x minus c squared plus y squared. Here, x minus c squared is x squared minus 2xc plus c squared. Okay, so we always cancel as many as we can before we do next square. So we already cancel y squared. Now let's cancel. Here you have x squared, cancel, c squared cancel. They are from two sides of the equation, so you can cancel them. And remember, we are going to leave this square root in one side, all other terms in the right hand side. So let's move this term to the left hand side. So minus 4a square root, move to the left hand side, it becomes positive 4a x minus c square plus y square is equal to, here is a 4a square. This is minus 2xc. This is plus. When you move here, it's also minus. It's minus 4xc, right? You move this to the right side, it's a minus. Minus 2 negative 2xc. It's a negative 4xc. Okay, they all have 4. Let's cancel 4, the coefficient of 4. Right? So far we have such a thing. And then we are going to square two sides. We square two sides. So we square this. Remember that uv squared is u squared times v squared. So it's a squared. We square two sides. We get a squared. And then second term square is x minus c squared plus y squared. Okay? The right hand side, it becomes a squared minus xc squared. This term, again, we apply this formula. Let's copy one more step. We basically just expand it. So the left hand side is x squared minus 2xc plus c squared plus y squared. This is a square square, u square. U is a square, square is a to 4, minus 2a squared xc plus xc squared. Okay, it looks very long because we have letters instead of numbers. If we have numbers, a lot of things can be cancelled. Anyway, let's simplify it. A squared x squared minus 2a squared xc plus a squared c squared plus a squared y squared. This is a to 4 minus 2a squared xc plus x squared c squared. See, here, this term, these two can be cancelled. So we cancel this term with this term. Okay, so we cancel them. We have a squared x squared, a squared y squared, c squared x squared, this a squared c squared. This term does not contain xy. We're going to move it to the right. This term contains xy term, so we move it to the left. Okay, so that's our strategy. So let's move to the left. You get a squared x squared minus c squared x squared and plus a squared y squared. You have 3 terms, 1, 2, and 3. This term is moved. So the right side you have a to 4. So this term will move to the right. It's minus a squared c squared. Okay, very good. We're almost done. So here you have x squared. We factor out x squared. We get a squared minus c squared. X squared plus a squared y squared is equal to, here we also factor out a squared. We get a squared minus c squared. Okay. Now let's discuss a little bit geometry. Check here. P P, F1, F2, these 3 points form a triangle. We know inside the triangle, the sum of 2 sides is greater than the third side. PF1 plus PF2 is exactly the sum of these 2 sides. It is greater than the third side. Third side has length 2c, so we know that 2a is greater than 2c because these three segments form a triangle. Sum of 2 sides is greater than the third side. Okay, so 2a greater than 2c, it is equivalent to say a is greater than c. Okay, so let's make the remark there. A is greater than c, then a square is greater than c square. A square is greater than c square. So a square minus c square is a positive number. So here, a square minus c square is a positive number. It's a positive number. Let b square is a square minus c square with b positive. So for example, if this is 2, then the b will be square root of 2. Then square root of 2 squared is 2. If this is 4, then b is 2. If a square minus c square is equal to 4, then you just let b equal to 2. So anyway, because here is positive, you can take positive square root. You get the principal square root, that is your b. Okay, so we let b square equal to a square minus c square because a square is greater than c square. So this is b square x square by this setting. And here is a square y square is equal to a square times b square. Okay, I do it in the fast way, but you can stop the video and go back and listen again. So basically, that's just a geometry from the triangle. The geometry from the triangle, and after you know it's a positive number, you take square root to get the principal square root. Okay? Okay, after you get this step, we're going to divide this equation by a squared b squared, divided by a squared b squared. All the terms over a squared b squared. And this part, you cancel b squared. This part, you cancel a squared. This part, you cancel all of them. So you get x squared over a squared plus y squared over b squared is equal to 1. This is our equation. Okay? So this is our equation. The equation of the ellipse, when you place 2 foci at negative c and positive c, plus when you let the sum of the distances is equal to 2a, then equation is like this, where b squared is a squared minus c squared. Okay? So this is the theorem on page 788. Page 788. When you have this standard setting, then you go through the computation, the abstract computation, you will get this very, very simple formula, very, very simple equation. Okay, so that's that is the equation. Now let's study this equation a little bit with a graph. I'm going to draw it here. Assume you have the ellipse looks like this. This is F2, this is F1. Remember, we say this is C, this is C. From this graph, you can see it is a very, very symmetric graph. It's a symmetric about y-axis. It's also symmetric about x-axis. So if I have a point here, this distance is equal to this distance, right? If P is here, the left distance is is equal to the right distance because it's symmetric, because here is a C. And also the sum of these two same number is equal to 2a. It implies this hypotenuse and this hypotenuse are both a. You have C here, you have a here, you have this relation b squared is equal to a squared minus c squared. Remember, if you write this in a different way, this one is exactly what? Is exactly the Pythagorean theorem. So it implies this vertical segment is B. It's vertical segment B. So the intersection of the ellipse with the y-axis is actually B, and also here this is negative B. You have B and the negative B. Okay, so that's two top and bottom points. And now let's talk about two vertices. Here the vertices V1 and V2. V1 and V2 are both on the x-axis, so their y-coordinate are 0. The y-coordinate are 0. And they are both on the ellipse. What is the formula? X squared over a squared plus y squared over b squared is equal to 1. So the coordinates of V1 and V2 must satisfy this equation because they have the points on the ellipse. Their y-coordinates are both 0. So you only have x squared over a squared equal to 1. In other words, x squared is equal to a squared. Remember, a is positive. When you take square root, you can let x be a or x be negative a. So one is a, the other one is negative a. So actually this part is a on the right side, this part is negative a on the left side. Left side of x-axis is negative, right side of x-axis is positive. So we get here a0 and the negative a0. So this x coordinate is a, this x coordinate is negative a. The coordinates of the vertices will be a0, negative a0. The coordinates of the y-axis of those two vertices, those 2 points will be 0b and 0 negative b. And the c is this part. This is c. Okay, so this one is the combination between the geometry and your algebra. Geometry, this is the geometry. Very good. Yeah, here is the geometry. No, let me see if maybe you can read it. Yeah, here is the geometry. We need the sum of distances equal to 2a, and the two foci has distance c and the positive, has distance 2c. They are placed balanced on two sides of a origin. And then you have the square root, the distance formula. Sum distance is equal to a, and you move one radical function to the right side, you square two sides, simplified, and you get another radical equation equal to a number. You square two sides and simplify, and eventually you reach this point. When we reach this point, we go back to the equation, back to the geometry studied. We see that a is always greater than c because the sum of two sides is greater than the third side. A is greater than c, then a squared is greater than c squared. The difference is positive. For a positive difference, you can take square root, you define the b, and you use b to simplify this writing. And you divide by a squared b, divide the equation by a squared b squared, you get the standard form. Okay, and after we get the standard form, we study this graph again. We figure out for those two up and down, top and bottom points, intersection points, they actually represented the b. One is b, one is negative b. For the left and the right vertices, the coordinates are represented by a. One is negative a, one is positive a. Okay, so that's the connection. And be careful, this is very important. Possibly you cannot, I just say possibly you may not be able to reproduce this process, but you must understand all the steps clearly. And and you should know why we can do this and why we can do that. Okay, so we got the formula. X squared over a squared, y squared over b squared is equal to 1. Let's do example. We will get equation. Find example. Find an equation of the ellipse with center at the origin one focus at 3, 0 and a vertex at -4, 0. Graph the equation. Okay, let's check. So focus is at 3, 0. It actually means this focus. So C is equal to 3. This part is a C0. This is a -C0, the focus. At 3, 0, center is the origin. So C is the 3, 0. Vertex is -4, 0, -A0. So A is 4. So you can see that this picture is very important when you do the examples. Okay, so A is 4, C is 3. What is B? We know that B squared is A squared minus C squared. So A squared is 4 squared, 16. C squared is 9. 16 minus 9, 7. In the formula, we don't need B. We need B squared. The denominator is B squared. So B squared is 7. That's good. So the equation is x squared. You see, x squared over a squared plus y squared over b squared is equal to 1. That's it. That is the equation. X squared over a squared plus y squared over b squared is equal to 1. So once we figure out the equation, we develop the equation, we will never go through that whole and long computation to find the equation. We just directly apply the formula. And the graph is more or less like this. You just label them. This is a 4, 3, 0, -3, -4, and this part is a square root of 7 because B is a 7. So B squared is a 7. So B is a square root of 7. This part is a square root of 7. So 1, 2, 3, 4. 1, 2, 3, 4. 2, 3. Okay, so this is a square root of 7. This is negative square root of 7. Sorry. Negative square root of 7. This is a 4. This is -4. This is a focus F2. This is a focus F1. That's a -3, +3, 0. And that's it. That is the graph. That is a graph. Clearly, when you use you draw it by hand, it's never precise. You just demonstrate. Okay. And there's one thing. There's one thing. So B squared plus C squared is equal to A squared. Remember that. This from the Pythagorean theorem. From here, we have this equation. So from this relation, we know that C is less than A. B is also less than A. Okay, so you should keep this in mind. A is the largest number among those 3 letters, and also because C, B are both less than A. This is A, this is B. So when you draw it, it's more or less flat. It's a flat. Okay, you cannot draw it like the vertical one. It's not correct. in this moment. It's not correct. Okay, so from the geometry, you should be able to get the algebra. This is a geometry. Focus, vertex, that's a geometry. Then you get the equation, that's an algebra. Now, if we have algebra, equation x squared over 25 plus y squared over 9 is equal to 1. Okay, when you get this, you see here 25 and 9. B is less than a, so a squared is 25. So from here you get a squared is 25 and b squared is 9. A squared is 25, b squared is 9. And then what is the c squared? B squared plus c squared is a squared. So c squared is also a squared minus b squared. It's 25 minus 9 is 16. C squared is 16, so c is 4. Remember, in the setting of ellipse A, B, C, all three letters are positive. All three numbers are positive. Okay, so that's very important. Those constants are positive for one ellipse. Okay, so even though in the equation you do not see C directly, but 25 minus 9 is exactly c squared. Okay, and C is useful when you try to describe the ellipse. So when you get this, let's say the equation is the ellipse with center at 0, 0. Center must be origin, center at 0, 0. The major axis along x-axis. The vertices are, see, 5 is a 5, 0 and a negative 5, 0. This time this horizontal distance will be horizontal line. Here is a 5, here is negative 5 because we have a. This graph is for the previous example. When we have the new graph, you will have 5 and negative 5. Foci are, you see, 4, 0 and the negative 4, 0. Okay, so we use a new data. And that's it. So you have the vertex, you have the center, you have the foci, you have major axis, and you got everything. And if you really want to sketch it, it looks like this. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3. Why I draw 1, 2, 3? 9 is the b squared is 9. B is the 3. 1, 2, 3. So those two top and bottom points have coordinate 3 and negative 3. Here is a 5 and negative 5. This is negative 5. It's negative 5, negative 3, 3. And the foci is a 4 and a negative 4. This is F2, F1. This is negative 4, this is 4. And center is here. Well, that's it in the rough way, hand drawing. Okay, so from the geometry, you get the equation. From the equation, you get the geometry. Algebra, you get the geometry. Okay, so that's possibly everything about the first standard position. When you place two foci on the x-axis, what happens if you place the foci on the y-axis? If you place the foci on the y-axis, technically you're going to go through this process, but the xy position will be interchanged. So when you get y, here is x minus c, x minus negative c. In the second case, it'll become y minus c, y minus negative c. So you do the similar step, you will get the following theorem. So an equation of the ellipse with center at 0, 0. So this moment, the center is always at the origin. Foci at 0, C and 0, negative C. Along the y-axis, this time it's vertical. Something like this. Okay, foci. And vertices at 0, negative A and 0, positive A. So here's A, this is C. It's negative C, negative A. So actually 2A is the sum of those two distances. 2A, the same setting, 2A is the sum of those two distances. And when we have this vertical case, the equation is like this. With b squared equal to a squared minus c squared. See, be careful about the second equation. The setting b squared is the same as the first one. The only difference is that this time y squared is over a squared. Y squared is over a squared. A represents the major axis, and b squared, x squared is over b squared. The difference between a squared and b squared is that a squared is always greater than b squared. Very, very important. Okay, so that's the difference. This time, y is a major one. Y is a major one. Okay, so now let's see. The computation is almost identical. We're not going to repeat it, but if you want, you can repeat it and see if you can really get this formula. Analyze the equation. 9x squared plus y squared is equal to 9. Okay, we analyze this equation. Well, in both standard position, the right hand side is 1. So you cannot have 9 in the equation. So we divide the equation by 9. We get x squared plus y squared over 9 is equal to 1. Here is x squared only without denominator. Without the denominator means it is over 1. It's over 1. And we know that b squared is less than a squared, or a squared is greater than b squared. So this is a squared. This is b squared. The bigger number represent a squared, always. The bigger, in the ellipse case, the bigger number always represent a squared. So a squared is below y squared, so it's a second case. Okay, the second case. The equation is about the ellipse with center at 0, 0, foci at, okay, this is a squared, this is b squared. C squared is a squared minus b squared is 9 minus 1 is 8. C squared is 8, then C is square root of 8. Square root of 8. Square root of 8 is 2 times square root of 2. How do you get 2 times square root of 2? You just consider square root of 8 as a 4 times 2. 4 times 2 is 8. Then square root of 4 is 2. So it's 2 times square root of 2. So when you get C equal to 2 times square root of 2, it's vertical. It's vertical. So the foci are at 0, 2 square root of 2, and 0, negative 2 square root of 2. This is the foci. Okay, vertex. Vertex are vertices are related to a. A square is 9. A is a 3. So the vertices at 0, 3, 0, negative 3. Okay, and then the major axis, major axis along y-axis. Major axis along y-axis. If we want to sketch it, it looks like this. So A is a 3. 1, 2, 3. 1, 2, 3. B is a 1. 1. So it's very thin. And 2 times square root of 2. Square root of 2 is 1.4 stuff. 2 times square root of 2 is 2.8. So it's here and here. 2 root 2, negative 2 root 2 is negative 3, positive 3, negative 1, positive 1. This is F2, this is F1. And that's it. That's the graph of equation. Okay. So, how do we know where is the major axis? You just check which denominator is greater. The greater denominator, its corresponding numerator will give us the major axis. Okay? And another example. Let's see from the geometry to algebra. Find the equation foci. Find an equation of the ellipse having one focus at 0, 2, vertex at 0, negative 3, and 0, positive 3. Okay, so when you see the vertex 0, negative 3, 0, positive 3, it is symmetric, so it implies the center is at the origin. The center is the midpoint of two foci. It is also the midpoint of two vertices. The center is the midpoint of two vertices also. It is at 0, 0. Because you add 0 and with 0 and divide by 2 is 0. Add a negative 3 with positive 3 divided by 2 is also 0. So the midpoint is 0, 0. The center is at the origin. Okay, then what do we have? Then we have, this is C. C is 2, A is 3. C is 2, A is a 3. A, then B squared. B squared is A squared minus C squared. Is 9 minus 4 is 5. B squared is 5. You got B squared, you got A. A is 3, so A squared is 9. So it's along the major axis is the y-axis. So x squared over 5 plus y squared over 9 is equal to 1. If you sketch it, you will get 1, 2, 3. This is 3. 1, 2, 3. This is 3. B is square root of 5. 1, 2. 1, 2. Sorry. It's greater than 2. It's my bad. It's greater than 2. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. So it's greater than 2. square root of 5 is greater than 2 because 2 is the square root of 4. Here is a focus and the focus f1, f2, vertex 2, and vertex 1. Okay, this is a 3, negative 3, root 5, negative root 5, 2 and negative 2. Okay, very good. So that's how the ellipse. Okay, so we have a few more minutes, and let me just emphasize something, and we will stop. When you have an equation, how do you know the major axis? For example, if we have x squared over 16 plus y squared over 12 equal to 1. Because 16 is greater than 12, so its major axis is along x axis. So a square is 16, b square is 12. Okay, and if you have x squared plus 4, x squared over 4 plus y squared over 16 is equal to 1, just because y squared has a bigger denominator, so the major axis is along y-axis, and a squared is 16 and b squared is 4. So here c squared is 16 minus 12 is 4. Here c squared is 16 minus 4 is 12. Okay, so directly from the comparison of the denominator, you can know the major axis. When you have the major axis, you can place the two foci. Okay, so this is first part of the section 11.3 ellipses. In the second part, we will see how do we move it. Remember that when we have parabolas, after we discuss the case vertices vertex at the origin, we moved the parabola. In the second part, we will move the ellipse and see what's a corresponding equation. Okay, we stop this video and we will start another video.